Now in a limit there are two results, two important limits. First result is limit of sin x upon x as x tends to 0 is 1. Limit of sin x upon x as x tends to 0 is 1. Say this is variable. Same number must be here. If here theta is given, there should be theta, there should be theta. If here theta by 2 is given, this should be theta by 2, this should be theta by 2. So whatever number is here, same number must be here, and that number must tend to 0. Then limit of this function is 1. As for example, limit of sin 5x upon x, x tends to 0. We want a limit of this function. Now look here. As I told, whatever number is here, same number must be here. This is 5x, but here it is not 5x. So what I do here, sin 5x upon x. Here I want same number, so I multiply by 5 in the denominator and divide by 5. Multiply, divide by 5. Take this 5 outside. This is like k. Limit of k times fx is k times limit of fx. Now say here, whatever is here, same number must be here, same number must be here. Here this is 5x, this is 5x. Now here there should be 5x. And we know that if x tends to 0, then 5x also tends to 0. Any number is going towards 0, then multiply that number by any number. That new number will also tend to 0. So x tends to 0 means 5x tends to 0. In short, we can say multiply by 5 on both the sides. So 5x tends to 0. And now you can see that we are getting this form. Sin theta upon theta, theta tends to 0. So by limit, by this result, this is 1. So 5. Suppose one more question on this result. Limit sin square x by 4 upon x square, x tends to 0. We want a limit of sin square x by 4 upon x square as x tends to 0. Now look here, limit x tends to 0. This is sin x by 4. Say here I am putting a space for one step. I am putting here space and taking next step. Say this is sin x by 4. Sin square theta is sin theta square. Sin square theta is sin theta square. Now say again, here if there is x by 4, same number must be here, x by 4. So here is x by 4, this is theta, so we want here x by 4. Then we can say limit of this function will be 1. Always keep remember, this number must be same. Sin x upon x. If here x by 2, put x by 2. If x by 4, here should be x by 4. This is 7x, this should be 7x, and same number must be 0. So this is the way of setting the number. Now this is sine square x by 4. Now this is what? It is x square by 16. Here x square is given. To write in this form, we must have here we must have here 16. But we cannot change value. Here no 16 is given. Denominator is divided by 16. We can't join anything extra. We cannot change value. So to maintain the value, what we do here, multiply by 16. So 16 multiply and divide by 16. So this is, here I am putting 1 by 16. Then 1 by 16 keep outside. Take limit inside. Limit of sine x by 4 upon x by 4 whole square. X tends to 0, so x by 4 tends to 0. So here a working rule is applied. Limit of fx square. Limit of fx square means limit of fx into fx. Now limit of fx into fx means limit of fx into limit of fx. Limit of fx into gx. Limit of product is product of individual limit. So here a limit of a square is the square of individual limit. In short, take limit inside. This constant we put outside, 1 by 16. So now this is of this form, x by 4, x by 4, x by 4. So this is 1. So it is 1 by 16. If here, see what is happened here. Here square is given. So we must have square of this number in denominator. This is x by 4. So its square is x square by 16. So that's why divide by 16, multiply by 16. If here cube is given, we must have cube of this number. So x cube by 64, that is required if cube is given. So according to that way, we have to set the number. Limit of sine of 5x upon x, x tends to 0. That already done. Suppose I put here sine of 7x. We want a limit of this function. Now see, here limit x tends to 0. Now what I do? Numerator is sine 5x, denominator is sine 7x. We can convert this into this form. See here 5x is given there in the numerator. So we need 5x in denominator. And if here 7x is given, then with a sine 7x we need 7x in that denominator. So to convert in this form, what we do? Here divide numerator and denominator by x. Divide numerator and denominator by x. That means we have done nothing. Now this is 5x. So here divide by 5, multiply by 5. This is 7x. So divide by 7, multiply by 7. Value remains unchanged. And now This is limit of fx upon gx. Limit of fx upon gx, that is limit of fx upon limit of gx. This is 5 by 7. It is like k. K can be taken outside. 5 by 7 take outside. And here limit of fx upon gx is limit of fx upon limit of gx. Limit of fx upon gx is limit of fx upon limit of gx after taking k out. Now here this is 5x, so we put here 5x. As x tends to 0, 5x tends to 0. Similarly, we put here 7x. So this is 5 by 7 into, this is 1 upon 1. So 5 by 7. That is required limit. One more result. Limit of 1 minus cos x upon x, x tends to 0 is 0. 1 minus cos x upon x as x tends to 0 is 0. Say here, whatever is this number theta, same number must be here. Same must be here. As for example, suppose we want here 1 minus cos 3 theta upon theta. We want a limit of this function. Now look the standard form. Whatever number is here, same number must be here. Here this is theta, 3 theta, but we don't have 3 theta. So what we do? Here 1 minus cos 3 theta upon theta, this is as it is. Now I multiply by 3, divide by 3, multiply and divide by 3. That means here 3 is multiplied, here we can say 3 is divided. So now it is of this form. 1 minus cos x upon x. Same number is created. 3 is like k. Take 3 outside. So 1 minus cos 3 theta upon 3 theta. Now theta tends to 0, so 3 theta tends to 0. So this is 3 into 0. Its limit is, by this rule, 0. So limit is 0. So that is application of this result. Now here, this is a sine of pi minus x upon pi into pi minus x. Say here, x tends to pi. Whenever any trigonometric function is given, then in most of the questions, we shall use this form. Limit of sin x by x, x tends to 0 is 1. So first of all you check here. Here is it 0 in this question? That we have to check. So here 0 is not given. Pi is given. So x tends to pi. So if x tends to pi is given and means this number is non-zero, then if difference of these two number is visible in function, then take that difference equal to y. Say here x tends to pi, difference of this number is pi minus x, visible. So take that difference equal to y. So we take pi minus x equal to y. If pi minus x given, take pi minus x. If x minus pi is given, take x minus pi. So we are taking substitute, means we are changing a variable. Given variable is x, and x we are converting into y. Everything this in question we are converting in y. So limit is equal to limit as x tends to pi. Here as x tends to pi, y tends to 0. So as x tends to pi, y tends to 0 is clear by this relation. So using these values, here limit is equal to limit, now replace x tends to pi by y tends to 0. Sine of pi minus x is y upon pi as it is, pi minus x is y. Now this is 1 upon pi, that part is constant, take it outside. So here sine y upon y, and you can see that we are getting this form. So its value is 1. So limit is 1 upon pi. Now see in this question, x tends to 0. Put here 0. So what is denominator? Pi minus 0, that is pi, which is non-zero. And if value of denominator is non-zero, no problem. Put direct value without doing any procedure. So here directly we are putting x equal to 0. So cos 0 upon pi minus 0. That is cos 0 is 1, this is pi. Here we couldn't put x equal to pi, because putting here x equal to pi, see what is happening, pi minus pi is 0. So denominator is 0, numerator will be pi minus pi. So sine 0, sine 0 is 0. So here we had 0 by 0 form. When in any trigonometric function you have 0 by 0 form, then we have to perform something like this. But if denominator is non-zero, by putting given value of x, say here it is pi, then don't perform any procedure, put direct value. Say here, you can see that if you put x equal to 0 here, cos 0 is 1. 1 minus 1 is 0. Put x equal to 0 in numerator. So cos 0 minus 1. Cos 0 is 1. So 1 minus 1, 0. So this is also 0 by 0 form. So we cannot put value of x. Put value of x only if denominator is non-zero. Otherwise we have to perform something. If it is trigonometric function, may be applicable of this formula. So here, continuing the procedure, x tends to 0. Here I am changing sign. Cos 2x minus 1, I put 1 minus cos 2x. Here 1 minus cos x. Because applying this formula, now in the next step, we can use this formula. 1 minus cos alpha is 2 sine square alpha by 2. 1 minus cos alpha is 2 sine square alpha by 2. If this is alpha, then applying formula in numerator, 1 minus cos alpha, if this is 2x, so here we have to put 2x by 2. 2x by 2, that is x. So this will be 2 sine square x. Now here 1 minus cos x. If this is x, so 2 sine square x by 2. So 2 sine square x by 2. So this 2 is cancelled. So this formula is used here. I am putting reason in front of this step. So that is, this is the simple form. Now this is sine square x upon this is sine square x by 2. Repeat it. Now we can convert this in this form. Say here sine square is given. Sine square. Here also sine square is given. So we need square of this number in denominator. Here also we need square of this number in denominator. So first of all, what I do? I divide numerator and denominator by x square. Divide by x square. So dividing by x square, here square of this number we have arranged. Here we need square of this number, and square of this number is x square by 4. So still 4 is missing. So divide by 4, multiply by 4. Whatever number is here, same number must be here. If here there is sine square, so take square of this number. If here sine cube, set here cube of this number. So that is the way of setting of number in denominator. Here square is given, then we set square of this number in denominator. Here square is given, we set square of this number in denominator, which is x square by 4. Then this 4, it comes in numerator. So limit x tends to 0, 4 into. Now this can be written as sin x upon x whole square upon. Here this can be written as sin x by 2 upon x by 2 whole square. Now we take limit inside. By working rule of limit, this is equal to, this is limit of f upon g. K take outside. Now limit of f upon limit of g, that is limit of f upon limit of g. So we give individual limit. So put a limit inside bracket. Limit x tends to 0, sin x by x whole square upon limit sine of x by 2 upon x by 2, x tends to 0. Now x tends to 0, so x by 2 also tends to 0, and here square. Limit of k into fx is k times limit of fx. Then limit of f upon g is limit of f upon limit of g. Then we have taken limit inside bracket. Limit of f square is square of limit. So applied working rules means distribute the limit individually. So this is, so here now this is, it's matching with standard form. Limit of sin x upon x, x tends to 0 is, this is 1, and here this is 1. So limit is 4. Limit of ax plus x into cos x upon b sin x. So in trigonometry, very useful and most important result which we are using here is limit of sin x upon x is 1 as x tends to 0. So find out that form sin x upon x in every trigonometric function. Say here sin x is given. So here we can set sin x by x, for which we divide numerator and denominator by x. So that is the beginning. Limit x tends to 0, this is ax plus x cos x upon b sin x. Now what I do, divide numerator by x and denominator by x. So this is limit x tends to 0. This will be a plus this x cancel cos x upon b into sin x by x. Now distribution of limit. A is constant. With a no any variable part is connected. Keep a as it is. Limit of constant is constant plus apply limit on this term. Then b put outside, apply limit on this term. That means apply limit individually. Distribution of limit in simple words. So that is a plus, now put here x equal to 0, cos 0 upon b into 1. This is 1. So it is a plus 1 upon b. Say here, this is similar method. Sin ax plus bx upon ax plus sin bx. This is given. Now first of all what we do? See, here ax is given, here bx is given, here ax is given, here bx is given. So first of all we divide by x. Divide by x. Numerator and denominator divide by x. This x is cancelled. Here x is cancelled. Now look this part. Here sin ax is given and here x is given. So because here ax is given, we must have here ax. So this part we multiply by a, divide by a. Similarly, here this is bx. See, to avoid confusion in the same step, this procedure I am showing in next step. This is equal to here sin ax by x plus b. This is a plus sin bx by x. Now that procedure I am showing here. This is ax, sin of ax. So multiply by a, divide by a. Here bx. So multiply by b, divide by b. Now distribution of limit. So that is a into limit of sin ax upon ax plus b as x tends to 0 upon a is constant, keep as it is, plus b put outside, apply limit on this term. Limit of sin bx upon bx. Now here ax is given. So here x tends to 0, so ax tends to 0. Same number we should show here. Here the number is bx, so put here bx. X tends to 0, so bx tends to 0. So then this value is 1, this value is 1. So it is a into 1 plus b upon a plus b into 1. So a plus b upon a plus b, so 1. Now here, this is equal to limit x tends to 0. Cosec x is 1 upon sin x. Cot x is cos x upon sin x. So this is limit x tends to 0, 1 minus cos x upon sin x. So this is limit x tends to 0. Say here 1 minus cos x. We have one result, 1 minus cos x upon x, its limit is 0. So what we do here? Here divide numerator and denominator by x. Numerator and denominator is divided by x. Now applying individual limit, limit x tends to 0, 1 minus cos x upon x upon limit sin x upon x, x tends to 0. Limit of f upon g is limit of fx upon limit of gx. Now we know that its limit is 0. Here limit of this function is 0 and limit of this function is 1. See, 0 allowed in numerator, not in denominator. So here we have written here 0. So this is 0. One more question. Suppose we want limit x tends to pi by 2 sin tan 2x upon x minus pi by 2. Limit of tan 2x upon x minus pi by 2 as x tends to pi by 2. If you put here pi by 2, see x tends to pi by 2. So if you keep here pi by 2, so pi by 2 minus pi by 2 is 0. So denominator will be 0, numerator will be 0. Tan 2x, so 2 into pi by 2, that is tan pi is 0. So this is 0 by 0 form. We are not allowed to put value. So what we do here, check difference of these numbers. Here given x minus pi by 2, take difference equal to y. Using substitute, we are taking x minus pi by 2 equal to y. X minus pi by 2 is y, so x will be replaced by pi by 2 plus y. And as x tends to pi by 2, as x tends to pi by 2, put here pi by 2, y tends to 0. So now using these values, limit is equal to, everything now we are converting in y. Limit of x tends to pi by 2, x tends to pi by 2 is now here replaced by y tends to 0. Tan of 2x, 2 into x is pi by 2 plus y upon this is y. So limit y tends to 0, this is tan of pi plus 2y upon y. So this is equal to limit y tends to 0, tan of pi plus theta is tan theta. So tan of 2y upon y. See, whenever we use substitute, everything must be in terms of y. Here also y must be visible, here everywhere y. No mixture of x and y is allowed. Now here, limit y tends to 0, tan 2y can be expressed as sin 2y by cos 2y. This 1 upon y as it is. Now say, using these terms, we are arranging standard form. So that is limit y tends to 0, sine 2y, below sine 2y I write here y, and 1 by cos y I am putting inside. This is inside. Sine 2y by cos 2y, 1 upon y. Now look here. This is 2y. So below sine 2y we need 2y. So here multiply by 2, divide by 2. So limit of this function is 1. So that is equal to 2 into limit y tends to 0, sine 2y upon 2y into limit of y tends to 0, 1 upon cos 2y. Distribution of limit. See, 2 into limit of this function into limit of this function. So this is equal to 2 into, now this is 2y, so put here 2y. Y tends to 0, so 2y tends to 0. So this is 1, and here 1 upon cos 0. Put you here y 0, so this is cos 0, and cos 0 is 1. So this is 2 into 1 by 1, so limit is 2.